It's Aspen Ideas to Go from the Aspen Institute. I'm Trisha Johnson. Nathan Wolfe is a virus hunter. In sub-Saharan Africa and Southeast Asia, he studied how viruses cross over from animals to humans when hunters are butchering wild game or when a wild bird infects a domestic bird like a chicken. Many viruses that affect people come from wild mammals, he says.
And so understanding those viruses is really critical to understanding sort of the denominator, if you will, of the viruses out there that can lead to pandemics in people.
Today, he theorizes on the origin of COVID-19 and explains how we can avoid another devastating pandemic in the future. Aspen Ideas to Go brings you compelling conversations hosted by the Aspen Institute. Today's discussion is from the Aspen Ideas Festival. Before COVID-19 began spreading across the globe last year, virologist Nathan Wolfe already knew what was becoming abundantly clear. The world is woefully unprepared to prevent the spread of novel viral threats. How can we be better prepared next time around? Wolfe says an always-on surveillance system would help keep epidemics from spreading like COVID did.
We should have always-on systems that are capable of monitoring for all of the viruses present, all of the microbes present within a society, and that's within reach.
Wolfe founded Metabiota, a data analytics company focused on epidemic risk. He was also a professor of epidemiology at UCLA. He speaks with Sarah Zhang, a staff writer at The Atlantic who covers health and science. They spoke on June 30th before the Delta variant triggered a new phase of the COVID pandemic. Here's Zhang.
You are someone who has warned about pandemics for a very long time and has talked about what they might look like. We're going to talk a bit about the future and hopefully how to prevent the next pandemic, because I think it's pretty safe to say we don't want to live through this again. It's been a really long and isolating year and tragic for some people. But, as someone who has been thinking about this for a long time, has COVID played out like you predicted, or have there been things that surprised you?
The way that I think about these events, we model them, and so you can actually model a whole range of different potential events. We're actually at the point where we can conceive of modeling certain parameters, certain characteristics of all future events. But the nuance, the idiosyncrasy that plays out is always something that's a bit unexpected. For example, some of the political dimensions, some of the informational features were things that are just nuance and that you'd have to really model in a way that was a movie or an art piece to get to that quality of nuance.
Yeah, I feel like what was so hard is people would often ask me as a journalist, what's going to happen? What's going to happen in the spring? What's going to happen in the fall? And the answer is, it's not just like, you're not just plugging in numbers about the virus, right? It also depends on human behavior, and human behavior is so hard to model.
I think that's a really important point, which is often we think about the solutions to these problems as being within the domain of science, and certainly science has demonstrated in such a remarkable way its capacity to manage this type of phenomena through vaccines, while we failed in other ways we'll talk about. Yeah. But I think it's important to recognize that the kinds of health communication, risk communication topics are deeply central to how these events play out. And I do think that these will be areas that will be quite critical in the future. How do we have a risk-literate population? I live in San Francisco, and I have a little boy that's 5 and a little boy who's 6 years old. And my 5-year-old was out playing, and the reality is for under 17-year-olds, the rate of mortality for this virus is exceptionally low. My boys were more likely to have died of influenza over the last year than COVID-19. But most people don't know that. They don't realize that, for little boys outside playing, certainly these days in a post-vaccine America, their chance of falling down and hurting their head is greater than their chance of getting COVID. But how do we get a population that is not hesitant to vaccines, and how do we get a population that understands these risks? I think this is one of the major learning events of this event and will be something critical for the future.
Yeah, well, I think one of the difficulties, if we rewind 5 years ago about talking about pandemic risk, is that it's a very small risk, but when you get the bad outcome, it's very bad, as we've learned. So I guess I want to talk a little bit about where pandemics come from and where viruses come from. And we tend to think of viruses as things that infect us, humans, but a lot of viruses actually come from animals. And so why and how? And you've done a lot of work in the field where you're actually tracking how people are interacting with animals in Central Africa and Asia. So tell us a little bit about that.
That's right. So when we think of viruses, it's useful to stop and take a moment that the vast majority of viruses on the planet are not even concerned with, not only not concerned with humans or mammals, they're not even concerned with eukaryotic systems. Most of the viruses on our planet infect things like bacteria and archaea that live in oceans and live in soil. There's a very small percentage of viruses that are relevant to humans, but of that group, the majority of them exist in wild mammal populations, to a certain extent wild bird populations, but we can go back in history and look at all of the major historical events and find that all of them virtually, the vast majority, are viruses that cross over from mammals and in a few cases from birds into human populations. And so understanding those viruses is really critical to understanding sort of the denominator, if you will, of the viruses out there that can lead to pandemics in people.
And so what do those interactions that allow them, what do they look like? I mean, is this like a bird poops on me and I might get bird flu? Like what are we worried about?
Yeah, and there is an entire body of study which is the interface between human and animal populations. And I did spend a good chunk of my career working in places like sub-Saharan Africa and Southeast Asia, trying to look at the interface between humans and wild animal populations. And this can vary from very intimate biological connections, such as we see with the hunting and butchering of wild game, which is obviously going to permit viruses from any of the different tissues present in animals to potentially move into human populations. But it can also be interactions that are more indirect. For example, a wild bird, perhaps spreading a virus to a domestic bird like a duck or a chicken, which could then potentially jump to a pig. And so there's a number of different ways in which these viruses are sort of pinging at us as a humanity, and that they can mix around and evolve in their process of moving into human populations.
And when you were working in sub-Saharan Africa, you were working with hunters, you were kind of watching them and seeing them butcher bushmeat. How did you get locals to trust you? I mean, no offense, you're a foreigner and you're kind of coming in and asking for their blood sometimes.
Yeah, and this is the right way to do this work is with local scientists. And so the reality is, all of the countries that I've had the good fortune to work in, there's been a range of phenomenal scientists, Ubal Tamofe, for example, who I've worked with for now 20 years in Cameroon. Ultimately, this needs to be a local effort in order to engage in, public health monitoring of virus populations. And so I spent a lot of my time doing this work, but it wasn't necessarily me, it was teams of individuals that were having this interface. But trust is critical in long-term work, and really trying to explain to people openly what the risks are, and having a public health communication associated with these kinds of research efforts.
And how dangerous is the work of going out and looking for new viruses that we don't understand yet and know nothing about?
You take tremendous precautions when you do this sort of work, and there certainly are dangers associated with it, but there's ways to do precautions. And let's not forget that the work is occurring in the context of a daily interface between wild animals and humans that's always going to be more than an order of magnitude more than whatever a particular public health official is going to have in that environment.
Yeah, I read a profile of you, I think in the New Yorker, that describes you and your team watching a young woman butcher a monkey that her husband has just hunted. And she's there, barehanded. There's blood everywhere because you're butchering an animal. That is what happens. And you and your team are standing by, and you're all wearing face masks and gloves. And that's just such a bizarre image, right? Like, of course, this is what she does all the time. You can't exactly force her to wear gloves, but you still have to protect your team.
Yeah, there's a range of important ethical and public health issues that you engage in when you do this sort of work. And one of them is really sort of sustainability. If you're going to be utilizing masks and gloves in a way that's sort of sustainable, that's a very, very different kind of effort. And I mean, frankly, it's very easy to misuse gloves, and it's very easy to clean hands, and that's something that I'm often struck with during COVID, is that often you see individuals who are wearing gloves, and the reality is it may very well be that that is less safe than not wearing gloves in circumstances.
Why would it be less safe?
Well, because you can wash your hands easily. If you've been trained appropriately in using gloves and masks, you know exactly how to dispose of them, how to utilize them. You know, they're generally one use for gloves. So if you're in a situation where people are going to be reusing gloves over and over again, it actually can facilitate risky activities and risks associated with those kinds of things.
Yeah, I remember when I first learned to work in the lab, like learning how to take off a glove without touching it was one of the first things you had to learn.
That's right, and how often you change a glove, and in some settings, you know, there may be an incentive to reuse gloves, which often is going to be more risky than effective hand washing.
I see. Well, we've been talking a lot about how animal viruses are spilling over into humans, and this is happening constantly. Most of the time, these viruses, they don't become a pandemic because they're not very good at spreading from human to human. In very rare cases, that does happen, and then we get a pandemic. And so, you know, that is obviously the prevailing hypothesis for where we think COVID came from. It was probably maybe a bat virus that maybe jumped into humans, maybe through another animal. We don't know, we cannot trace the entire lineage yet because it's really difficult, right? It's like looking for a needle in the haystack, and even with SARS, that took many, many years. But there's also a lot of questions right now about could this virus have come from a lab? And I think that's why I wanted to ask you about the risks of this research. So I know lab leak is a pretty vague term, so just wanted to spend a minute to unpack it. You know, it can mean a bunch of different scenarios. Like one one could say, like, was this a virus that was deliberately released and deliberately engineered? And I think we can agree that's pretty far-fetched. This doesn't look like a bioweapon. Another scenario is this a virus that was deliberately engineered but accidentally released? And that doesn't have to be nefarious. You know, scientists have conducted what is called gain-of-function research. And this is where you take something like a bird virus, for example, and then tinker with it a little bit and see if it's a little bit better in affecting mammals. And we do this because we want to understand how that crossover from animals to humans actually happens. Most scientists I've spoken to say that this doesn't look like a virus that's been engineered, and I think maybe you might agree with me about that, though I'm curious to get your thoughts. But that brings us to the third scenario, which is this is a natural virus that was accidentally released. And could it have been that a scientist who was collecting bat samples or was working with bats was accidentally infected? And so I think I just wanted to ask you, like, given that there are some risks involved with this research, and you've done some of this work where you're going out and looking at bats, how do we think about balancing those risks with the knowledge that could be gained to stop these pandemics?
Yeah, so again, just to summarize, the way that we normally think of these, the introduction of these kinds of viruses would be natural, accidental, or purposeful. Nobody's really considering COVID-19 from a purposeful perspective. It's more of an accidental or a natural perspective. The reality is that we know the history of a whole range of different viruses, and most of these are natural transmission events. We don't have enough to say clearly what's happening in the case of COVID-19, but I would also encourage us to ask the question of why there is such a focus, why there is such an interest from the media or individuals. Certainly this will be part of the narrative. The story of how this happened is going to be important. In the case of HIV, it took us decades to find out how HIV crossed into human populations. In the case of SARS, it took us a decade. And my big question when it comes to the origins of COVID-19 is, what does it really change about what we do right now for COVID-19? And I think the answer is nothing. And what does it change for what we do for future pandemics, which is the question I focus on? And I think that there's really not much that it tells us about that as well.
Well, what about biosafety and like lab safety?
No, and again, what I would say is no matter what the origins, look, myself and my colleagues have been in a long-term discussion about gain-of-function research. There's nothing new about asking questions about the costs and benefits associated with doing gain-of-function research. And it's also clear that I've spent a good amount of time in my career focused on lab safety and the whole range of biosafety features which are critical when you're developing laboratories. And I think that it's a yes and. Clearly, most of the risk that exists for humanity in the future will be from natural introductions. And so whatever systems we come up with that are going to address these risks are going to have to focus, as they have in the past, on natural transmission. Either way, it's also important that we have the capacity to monitor individuals who work in laboratories, and I think that's going to be, no matter what the result of this, a critical and very valuable outcome. It won't be the beginning of that work, but I think that there'll be a reminder and intensification of that work. Most of the US government partners we work with that are often discussed in the context of working on natural transmission have a huge percentage of their less sexy programs that are laboratory safety and these kinds of issues. And I think it's going to be a very important area for the public and for policymakers to think about gain-of-function research, which really is a question that's a deeper question and goes beyond what scientists should really be commenting about this work. We can talk about the benefits and the costs, but ultimately society is going to have to think about the values and costs associated with this research. And no matter what ends up being determined, if there is clear determination, there are still questions on HIV origins that remain unknown to this day. But whatever it is, it's very clear that the focus will be on ameliorating the future events, and it'll have to be in all three of these different dimensions.
Yeah, well, so on ameliorating future events, like what kind of, you've talked about like a kind of always-on surveillance system to kind of figure out, to see a pandemic at its birth. So how do we do that? What clues are you looking for?
Let's say it this way. It's very interesting for me as I'm an applied scientist. So I've had the good fortune to do some basic research in subjects like shadow life that are totally unrelated to the nature of pandemics. But fundamentally, I'm an applied scientist. And as an applied scientist, you have to continually ask yourself two questions. Number one, what is the objective of my work? And that can change. Number two, what is the technology that permits me to do my work? Because that's also going to change. And if you don't pay attention, you will end up missing the boat. I'm an applied scientist, and I continue to be focused on what I've been focused on over the last 20 years, which is how do we decrease the chance that we have these devastating pandemics? Now, today, I think of this in a fundamentally different way than I did even 5 to 10 years ago. And again, I think this always-on surveillance, always-on monitoring is a critical feature of what humans need. But I think there's two pieces to it. One is sort of early detection, right? The first time you see a new virus that's entered into human population. And I've spent a decent percentage of my career thinking about early detection. But the other feature to it is the dynamic capacity for populations to respond as a virus has grown, right? So let's think about COVID-19. It's a perfect example. We might have been able to detect it earlier than we did. And it wasn't our epidemiological systems that detected it. It was this archaic version of frontline workers saying we're seeing people dying, right? This was a failure of that epidemiological system. But I might ask the question of, was what led to the disaster? Was the amount of time that we took to detect the event? And my sense is that that's really not the reason that the devastation was. It was that, think of what we needed to do. We needed to set up COVID-19 testing in different states. We set up different systems, even to this date, different countries. We don't have standards. We don't have the capacity to compare apples to apples, COVID counts from place to place. And we had to stand this up from scratch. And it was those months that I think were most devastating in terms of the impact of this. So interestingly, I've spent a lot of my career thinking about animals, about early detection. But where I spend most of my time thinking now is, yes, early detection is critical. But I think it's about having these always-on monitoring systems so that when there's a new virus and the next one, we shouldn't fight the last war. Right? We shouldn't prepare a system which is perfect at monitoring for COVID-19 or Ebola or HIV. Each of these are fundamentally different events. But I think whatever it is should be always on monitoring that can scale such that there's not the need to create a new testing diagnostic system, a new monitoring system that immediately as these new events occur, we know what states they're in. As quickly as we possibly can, we can dynamically relate these to response efforts. right? And I think, at least for me, part of the learning experience for COVID-19 was that early detection is critical, but perhaps it's the always-on, expandable, dynamic scanning and responding, this monitoring that we need to have as societies so that we're not having to scramble every time we have one of these events to stand up these kinds of systems.
Well, what are you interested in monitoring in this always-on monitoring environment? Like, what are the pieces of data that you are kind of looking at?
Well, it's been really a fascinating time, and technology has fundamentally shifted. So some of you may be familiar with wastewater monitoring. This is the idea, and again, I think we should be cautious because COVID-19 is what we think of as likely a very GI tropic virus. In other words, it seems to be very much associated with our gastrointestinal system, in addition to, of course, our respiratory system. So this is like SARS, was something that can be spread through fecal-oral transmission in addition to respiratory transmission. But for that reason, we see it in wastewater. And we can actually monitor wastewater to get a sense of the presence of COVID-19 throughout populations. Now, whether that will extrapolate to other viruses is unknown, but it's a new way of thinking of it. There's great work that's being done in many institutions looking at mosquitoes as environmental sensors. Can we collect mosquitoes who have blood meals? We now have the capacity to scan through blood meals to understand what are the animals being bitten by the mosquitoes, what are the viruses present in those mosquitoes, and this is great work being done by many institutions. We also have this remarkable new technology that I'm very focused on lately, which is sort of, maybe some of you have heard of the liquid biopsy. We call it cell-free nucleic acids. And with your permission, maybe it's worth talking about it.
Yeah, please do.
Because it does represent a fundamental shift in the way that we can think about these kinds of events. And so all of you will be familiar with amniocentesis. Okay, so amniocentesis is this very costly procedure and very risky procedure in order to monitor the genome of a fetus in a pregnant woman. Now, effectively, amniocentesis, now there's 6 million women a year who don't need to do amniocentesis anymore. And the reason why is because blood, which circulates in our body, we normally think of it as delivering oxygen to cells, and it certainly does that. But another thing it does is, by definition, each of those living cells in your body needs oxygen, so blood has to touch every one of them. And so when your cells die, and cells are constantly dying all throughout your body, including, in this case, in the fetus, there's bits of genetic information that end up in the blood. And one of the most critical biomedical discoveries of the last few decades has been the computational capacity to stitch together these little bits of nucleic acid. And one of the first public health demonstrations was to show that you could basically sequence an entire fetal genome from drops of blood in the periphery. And now, and I've been fortunate to be a part of some of this research, we've demonstrated we can do the same thing with microbes, viruses. So, and this is currently being done for clinical work in patients in places like the United States and elsewhere, but effectively, the way that we historically would know the virus is in you would be take a swab and a cerebrospinal fluid, and you'd need a liver biopsy, and I would need a blood specimen and a fecal specimen, a nasal swab. And so necessarily the notion of doing monitoring of populations was something we didn't even really conceive of. But now, with some blood, we can suddenly scan for all of the viruses and all of the microbes in your gut, in your nose, in your brain, and it really permits us for the first time, along with, I think, some of these other technologies, to imagine a world, and this is what I'm most excited by. I think we can now imagine a world, a future world, not one many decades from now, but one within a decade, where we can have a certain population that with a certain resolution, we know all the viruses within a group of individuals on, say, a daily basis or a weekly basis, right? And I know it sounds pretty remarkable, but think again to, say, GPS and geolocation, where we were a couple of decades ago. You know, we didn't have images of every piece of the planet, you know, a couple of decades ago. And I believe, and where I'm focused in terms of my own thinking and efforts, is can we reach a world where we have a weather map of viruses that's an accurate weather map, and where we can really say, within a certain degree of certainty, that we know roughly all the viruses in a certain population. And this is beneficial for early detection, but it's also beneficial because these kinds of technologies are agnostic to the particular virus you're looking for. So the COVID-19, part of the COVID-19 disaster that we've heard about and everyone's familiar with is CDC having to develop an assay for COVID-19. And the failures and successes they had with those are irrelevant. We should have always-on systems that are capable of monitoring for all of the viruses present, all of the microbes present within a society, and that's within reach. And so that's what I get excited about these days.
Yeah, that's really fascinating to think about. So I talk to a lot of geneticists who talk about, our new capacities with sequencing, like doing this cell-free DNA. But it seems like maybe one problem we're hitting is that we can generate so much data now with all of this DNA that we actually don't really know what to look for. Like there's almost more than we can computationally really grapple with. So how do we look for the signal in the noise when you're looking at literally every single microbe and virus in the human body?
Yes, there's two answers for me for that. One is baseline. So among the failures of our contemporary epidemiological system was that we just simply don't have baselines, dynamic baselines where we're following individuals. So if you know everything that's present in human populations, and Sarah, this is a very good point. There's a lot of viruses in this room, right? Most of the viruses are actually the viruses in the bacteria in your guts and in the bacteria on your skin and in the bacteria on the surfaces. But even if we look at the viruses currently infecting the human cells in this room, there's a huge number of different viruses. Most of those are going to have no consequence whatsoever. Now, if we have a dynamic baseline, we'll have a sense of what we have in the population, and so we'll be able to detect anomalies. That's one answer. The second answer, I think, is a very important one, because technologies like this cell-free nucleic acid technology permit two things. Number one, they permit not having to do all of the different specimens to get all of the agents in a particular individual. And that's very valuable. I think arguably the most valuable piece of that. The second, though, is they permit us to sequence everything. And a lot of it is going to be unknown unknowns. And I do think this has been a bit of a red herring. I increasingly wonder whether early detection may be a bit of a red herring, but also the unknown unknowns. Most of the important viruses that have led to pandemics in human population have been unknown knowns. Coronaviruses that were new, influenza viruses that are new. And so as a consequence, yes, there'll be a great deal to be gained and learned, basic research associated with the unknown viruses that these technologies give us. But a lot of our risk is going to be simply the unknown knowns that we have, and those will be very easy to detect in these sorts of systems. That will not be noise.
Well, I'm also interested, just to geek out a little bit, in the unknown unknowns. Like, one of the reasons I like talking to virologists is that they always tell me about these incredible obscure viruses that we've not heard about, but a lot of us have inside us. So I was wondering if you just had like a favorite obscure virus you'd like to tell us about.
Well, it's sometimes the more interesting viruses are the ones that are not obscure, but they're present in everybody.
Obscure in the sense that they may be in us, but we don't know about it.
Yes, like, what is it? TTV is a virus which is present in just about everybody. We don't know what it's associated with it, what it does. It doesn't seem to be harmful. So look, for me, and I must say, I love the unknown unknowns. And there is a basic scientist deep down in me, and I'm interested. I spent years doing a research project where we looked for non-nucleic acid-based forms of life. And we didn't find any, but the question was, can you develop an assay that would see life independent of the DNA and RNA that we know is out there? But I do think, particularly at this kind of moment in history, it really is a focus on what are the things that are going to be important for future pandemics? And so I'm constantly trying to smack that part of myself down, which wants to ask the obscure questions. Now, there is one exception.
Let's hear it.
Well, look, in terms of not fighting the last war, there was a very important war that we haven't finished fighting, but we've basically forgotten it, which is HIV. Now, HIV is a very, very interesting virus in a range of different ways. But one of the ways that it's interesting, and most people don't know this about HIV, is if you take a look at the time course of an individual who's been infected with HIV, and this is the time, and this is the amount of viruses that are circulating in their blood, immediately you get a boost in viral loads. There's a lot of virus circulating in the individual, and then it's controlled by the body for years before you start seeing AIDS symptoms. Yet most of the transmission of HIV occurs in what we call this primary infection period, where you wouldn't even know. Many people don't have symptoms, and the symptoms they have are going to be very generic: fever, some body aches, etc. As a consequence, HIV, if we're just looking for syndromes, you would miss a virus like HIV, because by the time you start seeing the symptoms, most of the individuals will have already been infected. And if you imagined an HIV that was an order of magnitude more transmissible, by the time we started seeing the individuals who had symptoms, it would have been too late. And so as a consequence, anomalies, even if they're not associated with syndromes, are things that we need to, that's why the sooner we get a baseline, the better it is, right? Because if you think about a baseline starting in 1970, well, that would have been a baseline that permitted us to see the anomalies of HIV. And so we have really no time to waste.
I feel like talking to you that going through this period with COVID has made you rethink a lot of the things that you were thinking on earlier in career. Like you were saying, maybe early detection is not as important as you used to think it is. Is that right?
Look, and I don't want to overstate that. Some of this is the kind of pendulum swing. As I spent a lot, I think early detection is critically important, and certainly HIV was a perfect example where early detection would have made a massive difference for that particular kind of agent. Now, the kind of agent we've experienced in COVID-19, I'm not saying early detection wouldn't have been important, but given the failures that ended up sort of cascading after the detection of it, it really wasn't, our failure was not going to be, in the United States, for example, was not going to be changed so much, I believe, by a month or two. But I'm not saying early detection is not important, but it's sort of, where is the technology? And early detection will always be challenging. Having an always-on monitoring system in the United States or in other countries that permit us to protect our populations and to scale rapidly the dynamic monitoring and response that's necessary to quench and control these epidemics, that's something which is clearly within sight. And again, it wasn't always what I was most interested in terms of viruses, but I think it's what's most important. Ditto with animals. I was fortunate to be part of this, a great program called the Global Virome Project, and I would encourage you all to take a look at it. And the idea here is to go beyond the baseline in human populations and to get a baseline in all of the animals out there that have the potential to contribute viruses that could lead to pandemics in human populations. And again, technology has made this a conceivable thing to do, where we really know enough about the animals that most of these pandemics come from, and we can sample them, that we could go out and get 90% of the viruses in the world that have the potential to infect humans. And I think it's very important. It's the denominator. You need that denominator. And so I'm not saying that animal monitoring and understanding those viruses is not of importance. I think it is. On the flip side, I also am constantly trying to rethink about what technology we have. And one of the most remarkable features, and again, we shouldn't assume this will always be the case, was we had a sequence very quickly after some of the first cases that were identified in Wuhan. We had a sequence, and then we had the development very rapidly, and next time it'll be more rapidly, of these mRNA vaccines. A lot of the work that I historically did thinking about animals was in a world that didn't have that quick of an adaptive response between identifying a virus and having an agent. And so, 15 years ago, when you couldn't imagine that, or even 10 years ago or 5 years ago, the notion that we needed to start these animal viruses down the pipeline process for the development of vaccines, such that when these events occurred, we wouldn't be taking 3 to 5 years. Well, if it's the case that we can extrapolate on these remarkable findings from these mRNA vaccines, the remarkable efficacy that many of us in this room are actually experiencing right now, that technology changes what's important if your objective is not, there's also a useful objective of understanding what's in animals for conservation purposes, for human knowledge, right? This is not just that feature. But if we're having a laser-like focus on managing and mitigating future pandemics, then we just constantly have to be asking it. And I do think it's a bit of a yes and. I'm not saying early detection is unimportant. I'm not saying, I'm just sort of describing my own kind of journey through these things. I think early detection is critical. I think understanding animal virus is critical, but I think that there's this piece of always on monitoring and thinking of a sort of a defensive population-based approach to being able to dynamically, within a closed loop, be able to understand all the viruses in the population and not to have to suddenly switch gears on your assays and your system when there's a new virus which has entered into a population.
I think that's a good question you're asking of like what new technologies do we now have that obviate some of these things. For example, with mRNA vaccines being so fast and as most of us are benefiting from.
In tax law, most people think the only color that matters is green. But after more than 2 decades of research, tax scholar Dorothy Brown discovered America's tax system is not colorblind. In fact, societal racism is deeply embedded in it.
Regardless of what Black and white Americans do, tax policy subsidizes white Americans and disadvantages Black Americans.
From attending college to getting married and buying a home, Black Americans are financially disadvantaged compared to their white peers. Brown talks about her book, The Whiteness of Wealth, in the Aspen Ideas to Go podcast. Find a link to the episode in our show notes, online at aspenideas.org, or on your favorite podcast app. Let's get back to today's conversation. Here's Sarah Zhang.
I have one more question before we turn to audience questions, which is that your wife is a playwright, Lauren Gunderson, one of the most produced playwrights in America. She's often written plays about scientists. Her last play was called The Catastrophist. The main character is a virologist, and his name is Nathan Wolfe.
Maybe I can ask my wife to stand up just so you guys can.
Well, now that I put you on the spot,
yes,
and you have the stage, what would you like to say for the record about your portrayal?
It is a character. It is not me, is what I would like to say. And so my wife, who many of you have been fortunate to meet over the past days, is the most produced playwright in America after Shakespeare, and she's fighting hard in that direction. But if you happen to be married to the most produced playwright in America, you learn very quickly not to see yourself in the characters, because there's constantly characters and there's little bits of everybody that you see there, and an early error you make in that role of being a spouse to someone like that is to see features of yourself. And I tried to apply the same principle. I mean, when Lauren writes, it's a study that has different features to it. It's a technical bit, and there certainly are, obviously in this case, pieces that reflect upon me. But some of the most interesting features of Lauren's play for me were, I don't know, the portrayal of my relationship to my father, or my Judaism, or things that were in some ways not even remotely related to virology or my life as a virologist. But yeah,
I feel like it must be both like enlightening and a little terrifying to see yourself reflected through someone else's eyes, especially someone who knows you so well.
I think it was a little bit like the frog being slowly boiled. Lauren, I think we should ask Lauren, but I mean, Lauren's take this was early in COVID, and she obviously has all these very close relationships with theaters, and one of her artistic directors at Marin Theater, Jason Minadakis, I think proposed, look, we need to keep theater going. This is an important part of human storytelling, of human lives, and we can find a way to create theater. And the interesting thing about The Catastrophist is it is somewhere between a film, it's a one-person play that was done beautifully by Bill Demerit, and that was filmed in a theater, but as a film. And so it's not like film theater, it's a new art form that's somewhere between film and theater, and you can stream it, and it really was a new artwork. And Lauren was originally resistant to it, And I don't remember if I had a particularly strong view one way or the other. I've learned not to weigh in too much because it never ends up well. But it was a fascinating process, and it was very impactful for me because there's so much in the play which is personal, personal features of my life, and it's a character, but there were parts of it that were, it's an honor. I've had a great career, but if you don't happen to be married to the most produced playwright in America, as a scientist like me, you don't end up with a play. So it was an honor to have a play written about me.
All right, well, let's move to audience questions.
Hi, and thanks for your comments today. So with what your research is developing in identification and the messenger RNA is providing for containing the virus, is this something that, the science is at the point where the next pandemic won't be exponentially larger because of these things, or are we not there yet?
Well, look, there's a couple of questions. One we touched upon before, which is I would be thoughtful. Again, mRNA vaccines and even vaccinology is not my area of expertise. But I think we should be careful to extrapolate that the remarkable efficacy we've had from mRNA vaccines for COVID-19 would be applicable to any of the other potential viruses that we could see. We don't even know all the viruses that could potentially infect us. That's number one. But number two, let's just say as a thought experiment, we said mRNA vaccines will be equally efficacious. And again, I think it's a dangerous assumption for not to be cut in YouTube in a way that says this. Even if that was the case, though, and even if we assume that we'll go from 9 months or whatever it was to starting to use these vaccines to a month or two, which I think is likely best case scenario, these viruses can do a tremendous amount of damage in a month or two. And so I believe that the notion that we should depend upon vaccines is a very kind of dangerous notion, right? Vaccines are clearly a critical feature of this, but we will need to have a baseline, we will need to do early detection, we will need to have always-on surveillance. We will need to, frankly, have financial mechanisms that are more effective. I spent much of the last couple of years thinking about, and it's not where my current focus is likely to be because I'm so interested and engaged in the monitoring, but is financial mechanisms associated with decreasing damage associated with these events. And it's very important to point out that as devastating as COVID-19 has been for human populations in terms of health and disease, and that's obviously, where the most important feature, the economic devastation of these viruses is tremendous. And we need to utilize financial mechanisms and insurance in the same way that insurance pools and minimizes risks for other disasters like earthquake and flooding. There's a lot of innovation that will go on outside of this traditional biomedical realm, whether it's, improving health communications, finding ways to mitigate financial danger, finding ways to utilize financial systems in particularly developing world contexts where there isn't resources like we've seen in some of the Ebola crises to rapidly respond to these kinds of events. And there's great mechanisms from the World Bank and groups like African Risk Capacity at the African Union that attempt to find ways to pool resources and have them move immediately into contingency operations in countries that don't have good funding in order to try to control events that will happen, right? Because again, don't think about China, don't think about coronavirus, right? These are things that are constantly entering into humans everywhere in the world on a day-to-day basis, right? Today, there's many new animal viruses that have entered into humans all throughout the planet, right? And so we need to make sure we are not in a mindset which is fighting the last war. I think that is a great point that was made in one of these other sessions.
Yeah. Are we over here with the baseball cap?
Hi. On the economic devastation front, obviously insurance is key. Any lease now for space is going to have a pandemic provision. If there's a pandemic, I don't have to pay rent. I want to switch to human behavior a little bit. So you talked right when you started, the risk for the elderly or vulnerable are great. The risk for young people, not so great. the Gen Zers and young millennials, did they miss their opportunity to be heroes during COVID, where they could have stepped out from the quarantine and said, okay, I'm going to keep our economic system going, go out, spend money, shop, eat, because obviously it was an economic disaster for small businesses and retail. So just like in World War II, where the millennials and Gen Zers of that period saved our country, did the millennials and Gen Zers here miss an opportunity to be heroes by taking the, quote, risk and saving our economy?
That's a great question. And a lot of that, I must admit, is not my own area of expertise. But I think risk literacy, making sure that our population understands relative risk. How many people died of smoking over the last year on the planet? Well, it was an order of magnitude more than died of COVID, right? Like, how do we think about these relative risks, and how do we engage in health communication such that we don't have problems with vaccine hesitancy, where people are not understanding the risk of a vaccine versus the risk to a population associated with a virus with known capacity to be devastating along all these different axes. But I think I do agree, and it affects me in my personal life, which is I do think that we're fortunate, and our school did such a wonderful job with the kids. But my little kid, first of all, the other thing is not fighting the last war. We still don't understand exactly why kids are largely spared the most substantive impact of COVID-19. And it could have very easily and more expectedly been under 10s and over 80s that had the equal vulnerability. And I would just encourage you to ponder for a moment what the world would look like if that was the case in COVID-19. But I think there's an opportunity to say to kids, you don't have to be worried. This is not a risk to you. This is part of your civil service, just like voting, just like jury duty, right? That it's not, we're saying you're not wearing a mask to save yourself, you're wearing a mask to save your community. And I felt like maybe some of that was missing, and that this is a great opportunity because, you don't know which populations are going to be vulnerable in the next one.
All right, let's do one more quick question. Let's do the woman right there in the hat.
About liquid biopsies, and you were saying how we could enter a time where people could take it daily, and you would have a GPS virus load in different communities. How likely would it be for people to even submit to something like that with giving information out to the general public?
Look, we're going to have monitoring currently occurs, whether it's in hospitals or blood banks. But look, the hope that I would have would be that given the impact of this kind of agent, that all of us would think that a part of our contribution, just like wearing masks, just like being vaccinated, is being a part of the systems that permit us to understand the viruses that are present in our communities to be able to save ourselves from these kinds of events in the future. Sarah, thank you for such a great interview.
Thank you. Let's thank Nathan.
Nathan Wolfe is the author of The Viral Storm and has published more than 100 scientific papers. He received his doctorate in immunology and infectious disease from Harvard in 1998. Sarah Zhang is a staff writer for The Atlantic. She's covered many aspects of the pandemic, especially the vaccine rollout. Their conversation was held on June 30th, 2021 at the Aspen Ideas Festival in Aspen, Colorado. Make sure to subscribe to Aspen Ideas to Go wherever you listen to podcasts. Follow Aspen Ideas year-round on social media at Aspen Ideas. Today's show was programmed by the Aspen Ideas Festival team: Kitty Boone, Keeleen Bretman, Katie Cassetta, Libby Franklin, Ava Hartman, Marcy Krivenan, Jonathan Melgard, Azalea Milan, and me. Our music is by Wonderly. I'm Trisha Johnson. Thanks for joining me.